Welcome back to Mr. Giordano's Calculus Hour, Part 2. So what we've just done is found the slope of tangent lines at specific points. But what if we want to find the slopes of tangents to functions at several points? What if I say, here's this function, I want to find the slope of the tangent line at this point, and this point. Now you have two options. You could do what we've just done above, all this work, 3 times, and get your 3 different answers. Or let's find the generic expression that will find the slope for us. Essentially what we're about to find here is what's called the derivative. We need to use the generic formula to begin with, meaning where we saw the c's before, let's just replace those with x's. Let's not plug any numbers in for those x's. Here's what this looks like. So what we want to find is the limit as delta x approaches 0, but we're not going to use c, we're just going to use x this time. X plus delta x minus f of x over delta x. We're not going to plug any values in for x right now. We're just going to input these into our function. Okay? So here's what I want to evaluate. I don't want to plug a number in for x. I want to just take x plus delta x and have that be our input for these x's up here. We're just going to input x plus delta x. So we have the limit as delta x approaches 0. We're going to plug x plus delta x in for these x's. So you're going to have x plus delta x squared minus 2 times x plus delta x plus 2 on the end. So this is what f of x plus delta x is. Obviously, we're going to have to clean this up. Minus the function itself. So minus this whole function. Minus parentheses, we're going to put the whole function in parentheses, x squared minus 2x plus 2, all over delta x. Doesn't this look fun? So now what we're going to do is expand and combine all our like terms in the numerator. We got a lot of algebra to do. That's okay, we love algebra. So the limit as delta x approaches 0. Let's square the binomial, so square the first term. Take the product and double it. So x times delta x and double it, so 2x delta x. And then square the second term. Let's distribute the negative 2, so minus 2x minus 2 delta x plus 2. And then let's distribute the negative here. So minus x squared plus 2x minus 2. All right, now the fun part. You're going to start to see a lot of stuff cancel out at this point. Notice you have an x squared minus x squared. They cancel. You have a negative 2x and a positive 2x. They cancel. You have a positive 2 and a negative 2. They cancel. And so what you're left with, notice in the numerator, every term has a delta x left, which means we can factor delta x out. So we have the limit as delta x approaches 0, we're going to factor delta x out. And so we have 2x plus delta x minus 2. The delta x's cancel. That was the whole goal of doing all that manipulation. And now we can take 0 and plug it in for delta x. And so we get 2x minus 2. So understand what 2x minus 2 is, because you could go through all this algebra, all this manipulation, and get here, and then have no idea what you just found. What we just found is an expression that will find the slope of any tangent line on this function that we want. All we have to do is pop in the x-coordinate, and it's going to calculate the slope of the tangent line for us. This is also known as, and I'm going to mention this down here as well, this is known as the derivative of the original function. But we found it using the whole definition and going through the limit process. Those of you in physics, yes, you know a shortcut that will find it. We're not going to get there yet. So this is the derivative, and this stands for slope of tangent line. This is going to find the slopes of any tangent lines we want at specific points. So what we want to do is find the slope at 3, 5, negative 1, 4, and 0, 2. All we care about is really the x-coordinates. Let's see how this works. So at 3, 5, if I want the slope of the tangent line at 3, 5, plug 3 into the x. So 2 times 3 minus 2 is 4. That means for this function, right here, this function, the slope of the tangent line at 3, 5 would be 4. Let's figure out it negative 1, 4. Let's plug negative 1 in for x. 2 times negative 1 minus 2 is negative 4. So the slope of the tangent line is negative 4. And then at 0, 2, let's plug 0 in for x. And you get negative 2. So the slope of the tangent line at 0, 2 is negative 2. This process that we just did, finding this expression right here, this process is called differentiation. This process is called differentiation. We just differentiated this function, and what we found when we differentiate, you find the derivative. And what the derivative does, it allows you to find slopes of tangent lines at any specific point on a curve. And essentially what this is finding is the instantaneous rate of change, the instantaneous velocity at any specific moment in time. That's really where we're headed with this, but that's what we're doing for right now. Some notation that you're going to see along the way. So how do you notate what the derivative is? Well, you're going to see some notation like this. The derivative of f of x we notate as f prime of x with little apostrophe. This stands for the derivative of f, and we read it as f prime of x. You might also see it written as y prime, also stands for the derivative. And another notation we'll work with is dy over dx. We read this as dy dx. And this means the derivative of y in terms of x. The derivative of y in terms of x, another notation. Okay, and you'll see all three of these notations. It's important to get comfortable with all of these. These are nouns. These stand for what the derivative actually is. These are nouns. Now, some other notation would be commands. How does a problem command you to find the derivative? Now, it could say find the derivative, or it could look like this. It could look like d dx of f of x. This is a command to differentiate this function. This is a verb. It's telling you to find the derivative. Another notation, less common, but you might come across it, is this. This is a command to find the derivative in terms of x. So these are verbs. These are action words. They're telling you to find the derivative. This is what the derivative would be. These are nouns. So the derivative definition, how do you find the derivative of a function using the definition of it? So if I want to find f prime of x, if I want to find the derivative of a function, we take the limit as delta x approaches 0. Remember what this is. It's important to understand your notation. This is those 2 points getting really close to each other. That change in x getting really close to 0. And then we just use the slope formula. F of x plus delta x minus f of x over delta x. This is your derivative definition. Important. We are going to eventually learn shortcuts to find derivatives, really nice shortcuts. But the AP writers, the people who write the exam, they know how to ask questions that force you to know what this is and how to use it. They will force you. And we'll get into questions like that later on in the semester, but they force you to know what this is. Even if you know the shortcuts, you will be given a question or two that you have to know what the definition is. Okay, so just be prepared for that. All right. So, moving on. Example 3. Find the derivative of g of x at 1, 3, and 3, negative 5 if g of x is 4 minus x squared. So they're wanting you to find the slope, that's what this stands for, derivative stands for slope. Find the slope of the tangent line at 1, 3, and 3, negative 5. So the first thing we have to do is find the derivative of the function. We want to find the derivative of g, okay? So we want to find the derivative of this g function right here, all right? let's find the derivative. So we're going to have the limit as delta x approaches 0, g of x plus delta x minus g of x over delta x. This is our definition. This is going to find the derivative of this function. And the way we use it, we are going to figure out what g of x plus delta x is. So the limit is delta x approaches 0. Let's input x plus delta x into the x right here. So we have 4 minus parentheses x plus delta x squared. That's our input. Minus the function itself. So minus, now you could put this in parentheses. I'm going to take a little shortcut, and I know that I'm just going to flip both signs. So minus 4 plus x squared. You're subtracting each of these terms, so it'd be minus 4 plus x squared over delta x. Okay. Well, we can clean this up a little bit. We can square that binomial. So 4 minus, now keep in mind, this is a quantity itself. When we square this, we're subtracting the whole quantity. So we're going to put this whole thing in parentheses that we're about to find. So square x, double the product, square the second. So we squared that binomial, minus 4 plus x squared. Next thing we want to do is distribute that negative. So limit as delta x approaches 0, 4 minus x squared minus 2x delta x minus delta x squared minus 4 plus x squared. A lot of this is just really heavy algebra. I mean, the confusing part is trying to understand the notation and what we're finding as we go through the problems. It's just you being able to apply algebra. So let's see, the 4's cancel. Negative x squared plus x squared, those cancel. And lo and behold, everything left in the numerator has a delta x in it, so we're going to factor that delta x out. So we're going to be left with negative 2x minus delta x. Delta x's cancel. And then plug 0 in for delta x, and so you get negative 2x. And again, understand what this is. This is the derivative of the g function. This will find slopes of tangent lines at any point along this curve. So we use it when it said find g prime at 1, 3, and 3, negative 5. Well, now we need to find those slopes. So the slope at 1, 3, we could plug 1 in for x, 1 into the derivative, and we get negative 2. So the slope of the tangent line at 1, 3 is negative 2. If we want to find the slope at 3, negative 5, plug 3 in for x, and we get negative 6. Oops, I don't know why I put parentheses there. That's the slope of the function at 3, negative 5. All right. The next question says, what are the equations of the tangent lines at 1, 3, and 3, negative 5? So notice what we just found. We just found the slope of the tangent line at 1, 3 is negative 2. We want the equation of the tangent line at 1, 3. I mentioned this on one of the first days in class that when we write the equations of lines, we're going to use point-slope form. You're going to use point-slope form, which is y minus y1 equals m x minus x1. In calculus, we rarely care about the y-intercept. So don't use y equals mx plus b and find the b value. We care about slopes at points, and that's why we use point-slope form, because this deals with slopes at specific points. So to use this form, you have to know two things from the line, the slope of it and a point from it. Well, look what we just found up here. We found the slope at 1, 3 is negative 2. We have all our information. So the equation of the tangent line at 1, 3, we would do y minus the y coordinate. so y minus 3, equals the slope, which we found to be negative 2 right here, and then x minus 1. This is the equation of the tangent line at 1, 3. And we can do the same thing with 3, 5. If we want the equation of the tangent line at 3, negative 5, it would be y minus negative 5, so y plus 5, equals the slope, which we found to be negative 6, times x minus 3. We don't have to distribute these out. We don't have to put them in slope-intercept form. It's not wrong if you do. It's just not necessary. And so that's how we just leave our answers. All right, last couple. Example 4. Find f prime of x for f of x equals square root of x, and determine f prime of 3 and f prime of 25. So understand, it's asking us to do two things. It's saying find the derivative of the function, so we're going to go through our limit process, and then find f prime of 3 and f prime of 25. What this is asking, this is new notation. This is saying find the slope of the tangent line at 3. We could have taken this problem up here when it said find g prime of x at 1, 3, and we could have said find g prime of 1. They mean the same thing. These things here, it's the same notation. And so this is just a quicker way to write it. So what we're asking for is what is the slope of the tangent line at 3? So first and foremost, we have to find the derivative. Woo! So we're going to do the limit as delta x approaches 0, f of x plus delta x minus f of x over delta x. Let's do it. Do it to it. So we're going to take x plus delta x, input it for the function. So we're going to have the limit as delta x approaches 0 of the square root of x plus delta x minus the function itself, so minus the square root of x, over delta x. All right, so we have an issue to encounter, and we've dealt with this issue before. We need to rationalize the numerator. We have to multiply by the conjugate. Woo! So we're going to multiply by the square root of x plus delta x plus the square root of x over the square root of x plus delta x plus the square root of x. Let's multiply. So we have the limit as delta x approaches 0. Let's FOIL the top. So when we multiply the square roots together, you just get x plus delta x. The outer and inner terms are going to cancel. That's the whole point. And then you have minus x. We aren't going to distribute on bottom because understand what the problem is. The problem is this delta x here. We need it to go away. That's what's causing our 0 in the denominator. So leave it separate. So delta x times square root of x plus delta x plus the square root of x. X minus x, those cancel. So you have x over delta x. Those cancel. So you have 1 left in the numerator. Now we've accomplished the goal of getting rid of this. We could take 0 and plug it in for our delta x. So we get 1 over the square root of x plus the square root of x, which is 1 over 2 square root of x. This is f prime. This is the derivative. This is f prime of x. That's what we just found is the derivative of the function. That's the derivative, and so we use it now to find slopes of tangent lines at specific points. So the rest of the question said find f prime of 3. So f prime of 3 means just plug 3 into the derivative. So 1 over 2 square root of 3. There's no need to rationalize. That's it. This is the slope of the tangent line at 3. And let's find f prime of 25. So 1 over 2 times square root of 25. So 1 over 2 times 5, so 1/10. That's the slope of the tangent line at x equals 25. So we're finding derivatives and using them to find slopes. All right. Example 5. Given this function, So if you want to stretch or whatever, I mean, I know it's a long video. I said that at the beginning. So we're just going to do it. Given this function equals 1 over x, where does f prime of x equal negative 1/9? This is a different question now. The other problems were saying, what is the slope at 3? Like this one said, what's the slope at 3? And what's the slope at 25? This one's saying, where does the slope equal negative 1/9? Now we're looking for an x value. But regardless, we have to find the derivative of this function. To do this problem, we have to figure out what f prime of x is. So let's find f prime of x. So to find f prime of x, we go through our limit process. The limit, as delta x approaches 0, of f of x plus delta x minus f of x over delta x. This finds us the derivative. So we input x plus delta x into the function. So we're going to have 1 over x plus delta x minus the function, so minus 1 over x over delta x. Okay, so we have a complex fraction. We have a problem here, but we know how to deal with it. We need to combine these fractions in the numerator. We've done this skill already in this class. We have to get common denominators and combine these. So I have to multiply this first fraction by x over x, and the second fraction by x plus delta x over x plus delta x. This is going to get us our common denominators here. We're going to have the same denominator, which means we're going to be able to combine our numerators now. We have x minus this quantity. So we have x minus delta x. You're subtracting the x and the delta x. Over that common denominator that we found, x times x plus delta x, all over delta x. So now we have that triple-decker fraction. And remember what we can do there. That bottom level, you can actually take this bottom level and pop it into the second row. We've talked about why, but it's a nice little trick. So your x's cancel. You have negative delta x over delta x, so the delta x's cancel. So you're left with negative 1 in the numerator. And now you can plug 0 in for delta x. And so you get, let's see, you have negative 1 on top, plug 0 in for delta x, so you just have x times x, so x squared. So the derivative of this function is negative 1 over x squared. This will find slopes of tangent lines for us. But the question says, where does the slope equal negative 1/9? So I want to know, where does this equal negative 1/9? Anytime you want to know what makes something equal something, set it equal to it. So set the derivative equal to negative 1/9. And we solve this equation and we get our answer. Well, they're both negative, so you can make them both positive. Just multiply both sides by negative 1. And it's a proportion, so just go ahead and cross multiply. So x squared equals 9. Square root both sides. When anytime you square root, remember you have to put plus or minus. So it actually happens at 2 different places. It said, where does the derivative equal negative 1/9? It happens at x equals 3 and x equals negative 3. At those 2 places. That means there's 2 places on this curve where the slope is going to equal negative 1/9. At 3 and at negative 3. Last question. What are the equations of the tangent lines when the slope is negative 1/9? So think about what you need to write the equation of a tangent line. You need to know a point and slope. Well, we know the slope, and from up above, we know there's 2 points where it's going to happen. So we're going to have to come up with 2 different answers. So we know the slope. We know one point has an x value of 3. But we need the y value associated with 3. So think about how you find y values at x values. You take the x value, plug it into the actual function, not the derivative, but the actual function. So 1/3. So that means at 3 comma negative 1/3, the slope's negative 1/9. We can write the equation. Y minus 1/3 equals negative 1/9 times x minus 3. There's one other place. It happens when x is negative 3. So plug negative 3 in for x, and you get negative 1/3. And we also know the slope's negative 1/9 there, so y plus 1/3 equals negative 1/9 x plus 3. All right, so as I said, it's very important when you find answers, think about what you found. Think about the notation we are doing. Don't just get excited and say, oh, I know how to do this, but also think about what did I do and what are we doing. Those are important questions to analyze as you go through and as you go through the whole course. It just strengthens your understanding and it's going to help you problem solve. So think about what we just did. So go ahead and you have some homework on Canvas now. Go ahead and practice. And if you have any questions, shoot me an email. I'll answer them. Come into AL. We'll work through it. Okay. But important lesson that we just covered. Good luck and Godspeed.